Okay, these notes are on estimating and simplifying radicals. Okay, and this is for if you're absent on Monday the 25th. Okay, so first, starting with a review, this we did last week, right? We did estimating. And what we estimated was square roots. So, like the square root of 28. Okay, now how did we go about estimating this? Let's take a look. What we're gonna do is we're gonna kind of create a little number line across the top. Okay, so what we remember is like, okay, if I take 1, right, that's the same as the square root of 1. The number 2 is the same as the square root of 4. The number 3 is the same as the square root of 9. The number 4 is the same as the square root of 16. The number 5 is the same as the square root of 25, and so on. So go ahead and just create this across the top for yourself, because you're actually gonna find it's gonna be helpful for both of the topics that we're gonna work on these notes. And it's also just like this kind of visual representation is just really helpful as a way to kind of keep it in your brain. Okay, so the number 11 is the same number as the square root of 121, right? Like if I simplify square root of 121, it's just 11, that's it, okay? So when I'm estimating a square root, so for example, like 28, okay, 28 is right here. It's like in between 25 and 36, right? So I'm talking about the square root of 28 right now. So it's like right here, it's like a little bit more than 25, it's less than 36. So what I'm looking for is a number that's like right here. It's in between 5 and 6, and it's a little closer to 5. So like I would estimate like in between 5 and 6, a little closer to 5, right? Because 28 is a little closer to 25 than it is to 36. I would say like, that's like 5.3, okay? All right, let's try estimating 80. Take a moment, pause, kind of look for yourself. What would you estimate 80 at? Okay, now look. For me, you could say, oh, okay, it's in between 64 and 81 and so on. You could kind of go through that whole process. But to me, when I see 80, I think, oh man, you know what? That's so close to 81. Like 81, if I square root 81, I get 9. So if I square root a number 1 below 81, I'm just gonna get a number that's just under 9. And you know what that is? 8.9, right? Like that is a number that's just under 9, right? Like if I have 8, it's 8.1, 8.2, 8.3, 8.2, and so on, 8.9, then 9. So this is right before 9. Okay, and then the last one, this is like a little bit of a trick question, but it's actually an easy one. I wanna really encourage you to just like pay attention as you're going through. So don't just always like, okay, what is it in between? Like, oh, what is it in between? No, like observe, like, oh, this is so close to 81. Like, oh, that's just easy. It's just below 9, 8.9. Look at this one. What's this one? Look, it's just the number 6. It's just 6. We're not estimating here. It's exactly 6. Like this one is just done. Okay, so kind of just like pay attention as you go, because there's going to be situations where you can make your life easier if you're paying attention. Okay, so estimating is what we learned last week. It turns out estimating is like actually not that useful, because this number is not exactly 5.3. Like this number is not exactly 8.9. It's like, it's an estimation. So we actually prefer to have numbers be exact when we're like using math, right? So I'm gonna show you how to simplify. This is gonna be the method number 1 right here. And when I simplify, what that means is I'm gonna take this and I'm gonna make it simpler, okay? But it's still gonna be exactly the right number, okay? So the first method that we use is called prime factoring. And here's what it looks like. We start by prime factoring the number. That means we think of two numbers that multiply, like 4 times 7. And when we see a prime number, we circle it. And if we see a number that's not prime, we continue to factor it until we get all primes like this. Okay, then once I have those, you're gonna write it out like this. So I'm gonna write 2 times 2 times 7. And notice what I've just done is actually just rewrite this, right? Like this is the square root of 28. This is also the square root of 28. 2 times 2 is 4 times 7 is 28. So I haven't changed the number. I'm just rewriting it in a way that's a little bit more useful to me. Okay, so now when I go here, what I'm gonna do is I'm gonna observe the doubles. Okay, look, that's a double. This is a single. The doubles are gonna go in their own house like this, and the single is gonna go by itself in its own house. Here's the thing about doubles. Doubles simplify, okay? Doubles simplify. Here's the reason. Think about what this actually means. This means, okay, 2 times 2 is 4. So this is the square root of 4. What's the square root of 4? It's just the number 2, right? The other, even better way to think about it is that this is the square root of 2 squared, okay? We know that squared and square root undo each other. So when I see something like this, it's just 2. Like, look, if I see something like this where it's like 5 times 5, look, this is just 5. Look, because this is the same as This is the same as the square root of 5 squared. You could think of it that way, or you could say, oh, 5 times 5 is 25, and the square root is 5, okay? But notice this is gonna be like a pattern all the way through, all right? So this just becomes 2. Now the thing is that this part doesn't simplify, because this is like one of those numbers that's irrational, it's a horrible decimal, there's nothing I can do to simplify this. And so this is as simple as it gets, so I just was able to simplify this part, and that is called a simplified radical. Okay, by the way, this is called a radical sign. This symbol is called a radical sign. Okay, let's do 80. I'm actually gonna just do the same numbers all the way through. Okay, so here, let's prime factor. 8 times 10 is 80. 5 times 2 is 10. Okay, and what I end up with this time, more factors, is 2 times 2 times 2 times 2 times 5. Okay, so again, let's look for doubles. Okay, so I have a double 2, another double 2, and a 5. Okay, so this double 2, this is the square root of 2 times 2. So you can view it like this. The square and the square root undo each other and it just becomes 2. Or you could view it like this. Oh, this is 2 times 2, that's 4, and the square root of 4 is 2. But either way, this just becomes 2, this just becomes 2. This does not just become 5, right? This is a single, it doesn't simplify. Only the doubles simplify. And then we don't just leave it as 2 times 2, we just go ahead and do the multiplication. Okay, now in this case, we had doubles on the outside, like we had 2 numbers on the outside, we just multiplied them together. Let's say, for example, there was like a 3 right here, like times 3, then that would also be a single. That would just go in here like 5 times 3, and then I would actually just multiply it here. 5 times 3 would be 15, right, inside. Okay, so if you ever end up with 2 numbers on either the outside or the inside, you just multiply them together. All right, and the last one, if I'm simplifying square root of 36, don't start prime factoring this, right? You know what this is. If you simplify this, what's the square root of 36? It's just 6. You're done, okay? Don't overthink. Okay, this is the method, okay, that you're gonna use, and you're gonna go ahead and try on each of the problems, okay? On each of the problems, you're gonna estimate the number, and then you're gonna simplify the number. So for estimate, you should be putting a decimal, and for simplify, you should be putting like a number root a number like this.